Our first lesson in our new unit is going to focus on parallel lines. The entirety of this unit deals with parallelism and lines that are perpendicular to each other. We'll have some Algebra 1 explorations, graphing lines in the coordinate plane, determining whether or not they are parallel or perpendicular. But our focus today is just going to be on parallel lines from a geometric standpoint, not focusing on the Algebra 1 yet, all right? And so there are some key vocabulary terms: alternate interior angles, alternate exterior angles, corresponding angles, and same side interior angles. We are going to determine the measures of angles that are formed when two parallel lines are cut or intersected by what's called a transversal, So let's first define that term. A transversal is a line that will intersect two or more lines. So here I have line L, line M, and then here goes line T, our transversal in this case. And this forms 8 angles. And of those 8 angles, we have special angle pairs. Now think back to one of our later lessons from the previous unit. We talked about vertical angles being congruent. We talked about adjacent angles in a linear pair are supplementary. And so we have some special angle pairs based on content and understanding from the last unit. That's going to be useful here. However, what we are going to explore in this lesson and in the remainder of our lessons is what do we know about angles up here as they relate to or compared to angles down here, all right? And the number of the angle, like what I number them, is kind of jibber jabber right now. We can number these 1, 2, 3, 4, 5, 6, 7, 8, or 1, 2, 3, 4, 5, 6, 7, 8. We can number it in whatever order we want. It has nothing to do with the number. It has to do with the location, all right? And so 8 angles are formed along with these special pairings. First, we know that angles 1 and 2 are alternate interior angles, as are angles 3 and 4. We know that they are on alternate sides of the transversal. 1 and 2 are on alternate sides of the transversal, and they are interior between these pair of lines, line L and line M. And so alternate sides of the transversal, interior between these lines. All right, so 1 and 2, 3 and 4 are alternate interior angles. Now, I don't say that 1 and 3 are alternate interior because I want to pair, I want to have special pairings with an angle from the top set of 4 to an angle in the bottom set of 4. All right, so that's why we pick 1 and 2 and 3 and 4. Not 1 and 3, not 4 and 2. Next, we have 1 and 4 are same side interior. 2 and 3 are same side interior. They're on the same side of the transversal, and they're interior between lines L and M. All right? 2 and 3, same side interior. 1 and 4, same side interior. But then we also have these exterior angles. We have the alternate exterior angles, 5 and 8, alternate exterior angles, 6 and 7. And you could say that they're same side exterior angles also. I'm just naming the ones that are relevant to us here. Alternate interior, same side interior, alternate exterior. We also have another special pair of angles that are referred to as corresponding angles. Now this one is a little more difficult to visualize, especially when these lines L and M are not parallel to each other, but hopefully the location here matters. I say that 1 and 7 are in corresponding locations. They're both in the lower left, all right? 2 and 6 are both in the upper right. 3 and 8 are both in the lower right. 4 and 5 are both in the upper left. And so they are corresponding pairs of angles. Watch that part again if you need to have a little more clarity on corresponding angles being in corresponding locations between this set of 4 and that set of 4. All right? And so what we're going to do in this example is you're going to notice that I flip the picture over a little bit. I've got line P and line Q, and then I've got our transversal T going this direction. So the picture is switched a little bit, all right, rotated. But that rotation shouldn't affect our understanding, all right? Because it doesn't change the properties of what we're visualizing, it just changes our perspective. And so changing the perspective can help with solidifying those ideas. Also, I changed the order of the numbering. So I have 1, 2, 3, 4, 5, 6, 7, 8. It's not kind of shuffled through there based on the order of the conversation that we had earlier. So I'm going to do this example 1, identifying angle pairs. Label this example in your notes. But a pair of alternate interior angles would be angle 2 and angle 7 would be alternate interior angles. All right, those are alternate interior angles. They are on alternate sides of the transversal. 2's up there, 7 is down there. And they are interior. They are between lines P and Q. alternate sides of the transversal, interior between the two lines that are cut by the transversal. A pair of same side interior angles. Well, 2 and 3 are on the same side of line T, and they are interior between lines P and Q. So angle 2 and angle 3 are same side interior. Determine one pair of corresponding angles. I'm just keeping with angle 2 here. I know that this angle and this angle are in the same location between this set of 4 and that set of 4. All right, they're both in the upper right corner. So I'm going to have angle 2 and angle 4. And then finally, one pair of alternate exterior angles. So angle 1 and angle 8 are on alternate sides of the transversal, and they are exterior on the outside of lines P and Q. So angle 1 and angle 8. What I would like for you to do, and then put a box around this in your notes, is you find another pair of each of these and put them in a separate little box so I can check that on your notes. Name another pair of alternate interior angles, another pair of same side interior angles, another pair of corresponding angles, and another pair of alternate exterior angles. You can pause the video if you want. I'm moving on. Now we have our postulates and theorems, all right? And these are going to detail the angle relationships that will help us create equations, solve for variables, etc., given parallel lines. So each one of these theorems and postulates has this condition, this hypothesis, that line A and line B are parallel to one another. If these lines are not parallel, think of the inverse of the statement. If A and B are not parallel, then this is not going to be true, all right? If this is true, then that will be true. That's how this is going to work for the next 4 slides. Postulate 2.1, the same side interior angles postulate. So this is a postulate that we just accept and believe that it's true. And we will use this then to prove some theorems. We're just going to believe this now. It's a postulate, so we're going to believe it. If a transversal intersects 2 parallel lines, then the same side interior angles are supplementary. So angles 1 and 2 in this picture will be supplementary if line A and B are parallel to each other. If they are supplementary, that means that the sum of their measures is 180. So I could have an algebraic expression for the measure of angle 1, an algebraic expression for the measure of angle 2. I could add those 2 algebraic expressions and set them equal to 180, combine my like terms, and solve for the variable, all right? And that would be the type of work that we will see in class next time. Theorem 2.1, so the first one was a postulate. This is theorem 2.1. This one's a theorem, so we can prove it, which we'll do either later in this video or in a second video. But the goal here is to show that the alternate interior angles are going to be congruent to each other. If these lines are parallel, then angles 3 and 1 are congruent to each other, meaning that they have the same measure. If I have an expression for the measure of angle 3 and an expression for the measure of angle 1, I will set those expressions equal to each other and then solve accordingly. All right? Just like we did with vertical angles are congruent, we set those expressions equal to each other and solve. Here, the alternate interior angles are congruent if these lines are parallel. Given this condition, this is true. All right? The numbering I want to speak to real quick. This was postulate 2.1. It's the first postulate in Unit 2. This one is the first theorem in Unit 2. Next, we have the second theorem in Unit 2 and the third theorem in Unit 2. And so just that's how that numbering works, FYI. All right, so theorem 2.2. The corresponding angles theorem states that if these lines are parallel, oops, I said A and B, that should say L and M. Let me fix that real quick. If L and M are parallel, if we have parallel lines, then those angles are congruent to each other. If L is parallel to M, if line L and line M are parallel, then these corresponding angles are congruent, and these corresponding angles are congruent, and these corresponding angles are congruent, and these corresponding angles are congruent. We can prove this theorem by applying the same side interior angles theorem, as we will see either, again, later in this video or or we can use alternate interior angles theorem. All right, if I have angle 3 right here, given that these lines are parallel, the alternate interior angles are congruent. These are vertical angles, therefore they're congruent. If angle 1 is congruent to angle 3 and angle 3 is congruent to angle 2, then angle 1 is congruent to angle 2 by the transitive property of congruence. There, I just did the proof out loud for us, so we don't have to write it down. Theorem 2.3, the alternate exterior angle theorem. All right? If A and B are parallel lines, then angles 1 and 3, the alternate exterior angles here, are congruent to each other. All right? And we can go through a series of steps to make that proof. All right? But angles 1 and 3 are congruent to each other. So we can use this information to have a situation where we either know the measures of angles and we can use that to generalize and find the measures of all the angles in the picture, or we can use it to create other equations and solve equations. Some of this we're going to do just mental math, and some of this we're going to do using what we know from previous lessons. For example, we know the measure of angle 8 is going to be 50 degrees because it's vertical with the one that's marked 50 degrees. All right? Angle 7 is going to be supplementary to angle 8 and to the one labeled 50 degrees. And so I know that this one is going to be 130. I can do that subtraction in my head. All right? Or we can write out the equation, the measure of angle 7 plus 50 equals 180. Subtract 50 from both sides, so the measure of angle 7 is equal to 130. All right, that's from previous understanding. All right, this is based on supplementary angles. This is based on vertical angles theorem. But then I can see some other things. For example, I know by the same side interior angles postulate that 50 and angle 2, their measures will add up to 180. So I know that the measure of angle 2 is also going to be 130. All right, I can say it that way using the same side interior angles postulate, or I can say these alternate interior angles are congruent given that these pairs of lines are parallel to one another. All right? Which then gives us that flexibility. We can say that these are supplementary, or we can say that these are congruent to find the measure of angle 6. So what I would like for you to do is finish this. Find the measures of each of these angles. You do that. You can pause the video if needed before we move on. All right? But that basically closes out our examples. All right? I'm not getting too heavy on the algebra. We're just kind of identifying those angle relationships, and we are finding the measures of angles. We will do some algebra in class, but for here right now, we want to make sure that we understand those relationships, which then will let us create equations in our practice. Here is a helpful summary of the content from this lesson. We have 4 special angle relationships: same side interior angles, alternate interior angles, corresponding angles, and alternate exterior angles that are new vocabulary for this situation when we have parallel lines cut by a transversal. You're going to see these angle pairs, and then of course these angle relationships when those lines are parallel. We can have that understanding. All right? So we're going to use that to have, of course, a great understanding of that content. Hopefully, I've answered all the questions and everything came through clearly. But if you do have any questions, pause and write down some of that content so that you can pause and write down those questions so that you can submit those onto Google Classroom, or you can type them up in the comment when you submit your notes, or you can be ready to ask those in class.